Alrighty guys, well, sorry to be doing this the first day of class. I know that you guys were probably expecting just to show up and then hear about the syllabus and leave. Unfortunately, you get to listen to me. Like Professor Kopp mentioned, I'm Brady Pitcher. I work for the Rainbird Corporation. Out of curiosity, I want to get an idea of how irrigation involved most of you are. So by raise of hands, how many of you would say, like for example, have installed an irrigation system? Okay, good. That's good. How many of you have done it professionally, like on a landscaping crew? Okay, good. How many of you have very little knowledge of irrigation? Okay, so about 50-50. Okay, good. So I'll try to keep it about in the middle then, is what I'll try to do. My presentation that I put together is not intended to be overwhelming. I realize this is the first day of class, and I don't want to bombard everyone with a bunch of information that you wouldn't remember by the end of class anyway. But as far as what we're going to be going over today, there's my title. I am an ASM PAAM in the company, which basically means that I oversee all of the specification in the state of Utah or landscape architects. I visit landscape architects in the state of Utah and help them understand how our product, how Rainbird product works. And then I'm also over public agencies in the state of Utah as well. So here's what we're going to go over today. First of all, I want you to learn a little bit about me. If you're going to listen to me for the time that I'm here, I want you to understand who I am, where I came from, what my background is. We'll go over just 2 slides of our stewardship with water. Quick history of irrigation. Most of our conversation today will be about an anatomy of an irrigation system. And then if you do have any questions at the end, we'll do that. So a little bit about me. This is a little personal, but I am the somber child in the bottom, right there in the middle. That is me. I am born and raised in Cornish, Utah. Out of curiosity, anyone know where Cornish is? I know there's a couple people that do. How do you know where Cornish is?
I drove out there one day.
You drove out there one day?
You have a great swing set out there.
We do have a great swing set out there. So Cornish, for those of you who don't know, is in Cache Valley. It's right on the border of Utah and Idaho. In case you're wondering about this as well, I gave a presentation last week and someone fell asleep. Just kidding. Thanks for laughing. I appreciate that. No, I had a torn ligament in my wrist and woke up from surgery to find out that I have to be in a cast for 6 weeks. So it wasn't very exciting. Grew up in Cornish. Grew up on a dairy farm. So I, from a young age, was involved in digging up the dirt, plants. I installed large-scale irrigation systems on our farm. So it's kind of ironic that I ended up in this job that I am right now. It's much better than farming. You know, don't tell my dad that, please. I am also, I'm a landscape architect. So I went through the program here at Utah State. So, and if there's anything I could tell you right now, being a landscape architect that I would encourage you to do, that I'm sure the professors here in the program may not tell you to do, is I would encourage you to get at least an internship with a landscape contractor. And why do I say that? Because your design ability and your design knowledge and understanding will completely change and broaden if you do that. I did that in my career. I spent a couple of years with a landscape contractor, and my design changed completely because of that experience. You understand how things go together, and if there's any complaint that I hear very, very often about landscape architects in the field is that landscape architects have no idea how things are installed. So what are they doing designing things for us? So that's my little soapbox. So I'll step off of that now and continue on the presentation. So I graduated in 2003 in landscape architecture, worked for a bunch of LA firms. I had my own firm for a while as well. In fact, if it's okay, I'll introduce actually Stephen Peden. He's a graduate student in the program here. This is Stephen. He actually worked with me for, how long did we work together, Stephen? About a year and a half. So he had to put up with me for about that long. Good experience, and he is going to be handing out some catalogs. So Stephen, if you wouldn't mind, I have some irrigation catalogs that he's going to be given to everyone that'll kind of go over a lot of what I'm going to be talking about today. So let's start here. As landscape architects, we have a stewardship to the land, and specifically I'm going to be talking about water. Here's a couple of graphics that I'll bring up that are kind of surprising. So of all the water that exists on the earth right now, 97% of it's salt water. And if you look at that small percentage, 1% of that is fresh water. Just 1% of the water in the entire world is fresh water. And that's what we're dealing with as far as irrigating. And then if you look at this as far as world population goes, we're about right there right now. The population is going to continue to grow, and what you will end up seeing over your career, and I've seen in my time as a landscape architect, water is going to continue to be a concern in the field of landscape architecture. It is a precious commodity that we're going to continue to want to conserve that as much as possible. And there's no way we can create more of it, is what it comes down to. There's a lot of attempts to do desalinization and a bunch of those. I'm not going to go into any of that today, but as far as that fresh water goes, that 1% is going to be 1%. Then I also just pulled this off of the U.S. Drought Watch on January 1st, as you can see. At any point in time in the year, you can go onto this website and check out where the droughts are happening. The darker the color, more of a drought. Go back a little while, and that red was actually over the Rockies. That's going to continue to be an issue. So that's why it's so important what we're talking about with irrigation, with water, because it's going to continue to be an issue. So as far as irrigation goes, a little history for you. Obviously, the first irrigation was river flood irrigation. The Egyptians actually, from this little illustration, the Egyptians introduced it in the Nile. They started diverting the water from the Nile and bringing it into their crops. It's still in the world today, as you look around, it's still the most common way to irrigate as well. And this is kind of a surprising number. Of the crops that are grown in the world, only 15% of those crops were grown with efficient irrigation systems. So most of it is actually grown in this form right here. The farm that I grew up on, that's how we did it. We had a canal that ran through our farm, and we drew from that and irrigated. So does anyone recognize this little machine here? This is what most of you have heard what we call now an impact head, what I called on the farm a rainbird head. This was the first invented rainbird head, is what this is. It was in 1933, Orton Engelhart filed a patent for this spring-activated horizontal arm. He wanted to find a new way to irrigate more effectively rather than flood irrigation, so he invented this in his shop. Pretty nifty there. A little bit more even way of doing it, and that's kind of where, at least in the United States, modern irrigation started. So we're going to refer back to this graphic quite often. If you want to review this graphic, it's on pages 2 and 3 in your catalog, so feel free to open to that. A lot of what we're going to be talking about today you're going to find in the catalog. It's not going to be in the same order that I discuss it. You'll notice that there'll be some tabs along the side that'll be broken into areas as far as valves, rotors, spray heads, and things like that. But what we're going to do is we're going to take a typical residence and go through the different irrigation parts of this residence. So first thing we'll do is we will start with the water meter. Has anyone ever installed a water meter before? It's a good thing because it's kind of a pain. So water meter, what is it? Anyone tell me what a water meter is? What's its function?
Measures the amount of water used.
Yep. So let's go back to this example right here. So for example, this is the roadway right here. That water meter comes right off the city main and comes in. That M on most plans, irrigation plans, is usually a square with an M for meter. That little weird thing next to it is a backflow preventer. That's this ugly looking guy right there. Backflow preventer does exactly what it says that it does. It prevents water from flowing back into the water main and contaminating the water main. And by law, in almost every state, it's required to have a backflow preventer even on residences. Next thing we'll talk about is controllers. So there's basically the controller is the brains of the irrigation system. That's where the controller, which I brought an example of one right here. This is more of a complicated one. This is more of a commercial grade controller here, but controller, as you open it up right there, these are individual modules that where each of the valve wires hook into right there. And this tells each of the valves when they go on to allow the water to go in to each of those different zones. Now this specific one here, this is really difficult with the cast. This specific one here, a lot of the controllers are being made now come with what are called modules, so that they can, it's very easy to just purchase the amount of stations that you need for the project. So if it's just one where you need 3, you just buy one module. Oh, what happened here? What is going on? There we go. So there's a couple things from an irrigation standpoint and water saving standpoint that controllers do. And I'm not going to go into detail a lot about each of these things, but for example, Professor Kopp talked a lot about soils and how different types of soils the water infiltrates differently. One of the features on most programs or most controllers is a cycle and soak, which means that basically the controller will turn the water on for a while, shut it off, wait until that water actually sinks into the soil, and then turn it on again. That way you don't get runoff. So if it just runs and runs and runs and runs, that soil has a capacity to it. Once it reaches that capacity, it's just going to run off. A lot of controllers as well have a water budget that you can say, I can only use this amount of water, so use it effectively. Anyone recognize what ET is? Anyone tell me what that is?
Stands for evapotranspiration.
Okay, so what exactly is evapotranspiration then?
That is a good question.
Okay, we'll talk about that later. Essentially what it is it is a way to measure how much water is lost, whether that be through evaporation, through a bunch of different methods, but you'll hit that a little bit later. A lot of controllers these days allow adjustments to the clock or the controller based on evapotranspiration, which is really handy because what it does is it takes in temperature, wind, solar radiation, and all those things, and makes adjustments to the clock. A lot of them also have a rain monitor. This is a rain monitor right here, for example. This is one of our rain monitors. Most manufacturers have one like it. And this one specifically will go to any clock. This right here hooks up to your clock, right there. And then this outside, this little guy right here, in fact, let's do this. This hangs outside, like for example on an eave. You see those little discs right there? There's these little wafer discs right there. When it rains, the rain will go down in there and this will sense if it's wet. If it's wet, it'll send a signal down to this that then is hooked to the controller and says, okay, we're going to cease watering because it just rained. So kind of a handy little thing there too. A lot of residences are getting more and more savvy to these things. If you think these things are only used in commercial settings, they're used a lot in residential settings as well. And as time goes on, we're probably going to see them used more and more as cities put water regulations together for residences. And we already did talk about modules for expandability. It's quite a bit easier to have modules. It's a lot more affordable as well. That way you only have to purchase what you need. Okay, let's go into valves now. So the controller, through a wire, is hooked to each of these valves, and the valve is what actually turns the water on. A couple of things that make up what a valve is. So they obviously receive the electrical pulse from the controller. There's a diaphragm. In fact, where is my diaphragm? There it is. This is an intersection, a cross-section of a valve on the inside. And I'll show you a video in the next slide that kind of illustrates how this valve works. But essentially, the water ends up coming in on this side. It lifts this diaphragm right here, and it allows the water to go through. That's what ends up happening. And like I said, I'll have a video that'll show that a little bit more. Here's the basic components of a valve. First of which you have your solenoid, which in this case, these are a little bit different valves than what I'm showing there in the screen, but there's the solenoid. The solenoid receives the electrical signal from the clock, and then basically allows this diaphragm to lift up is what that does, and allow the water through. A lot of valves also have a flow control. That's what this little knob right here is. If you screw that down, it actually pushes the diaphragm down and forces it to close. So that if it doesn't work for some reason by the solenoid, you can force it to close. Then the body is the bottom portion, and the bonnet is the top portion. The body and the bonnet in most valves separate so that if you need to pull them apart for repairs or there's something stuck in it, that's how you get into them. Oh, let me go back. And this, I'll have to apologize before this is a video, maybe a little bit cheesy, but what it shows you how the valve actually works. If it actually works. So this is the body and the bonnet. Undo the screws. Music really helps, doesn't it? It does. I mean, it makes me excited about it. There's the solenoid right there. You can pull that completely off. For serviceability, we've designed it so that you can take it off and rotate it out of there. This, more than anything, is kind of what I wanted to show you, is what's coming up. Okay, so this right here kind of shows you, as the water comes in, the solenoid basically releases the pressure that's on the top of the diaphragm right there. That solenoid releases some of that pressure, the air right there, allows the diaphragm to lift, and that's where the water flows through and goes through it just like that. This little thing right there, on a lot of valves, this is what's called a tick filter. Just filters the waters that's coming through. If there's any contaminants, it catches it before it goes in. This right here, a lot of valves have this as well. It's called a bleed valve, that if your solenoid is not working, you can actually manually turn that on. It allows water through and allows any debris to get dislodged. Okay. I won't bore you with any more of that right there. I know that was really exciting, though. So the rotors, we'll talk a little bit about rotors now. So I brought this nifty thing right here. This is my rotor stand. Sorry that you have to sit right in front of it. We'll turn the water on so you can get a fresh look at things. Anyone tell me the difference between a rotor and a spray? Anyone know? We're going to go over it just in case you don't know. What was that?
So doesn't a rotor go back and forth, sprays water
Yep.
back and forth, and the spray just
Exactly. So rotor, typically a rotor's larger. So for example, this is a rotor right here. A rotor, instead of just popping and spraying out, like he said, A rotor actually has gears in it, and it'll move back and forth like this. So most rotors are gear driven. If you look at the guts of that thing right there, it's pretty involved. You would think that a rotor would just be, there's an inlet and there's an out. That's just how it works. There's a lot of mechanics that goes into making a rotor work inside of there. I mean, there's everything from a filter system to some of them have a pressure regulator that regulates the pressure as it's coming in, that if it's too high, it'll bring it down. And then each of them as well typically have a nozzle that you put in there. And depending on how far you want that rotor to shoot, you just put in a different nozzle. Now typically, when you're thinking about when it comes time to design, rotors are used in this scenario right here between 15 and 80 feet. 80 is a long ways. In most residences, you won't be dealing with anything like that. Our large rotor right here, this one right here, for example, it's our 8005. It'll shoot up to 80 feet. And it's typically used in a ballpark situation is where it's used. In most homes, something like this is our 5000. This will shoot up to 50 feet. Typically, it shoots around 25, depending on the nozzles, what it shoots, which is very typical for most residences. So just keep that in mind, and I know we'll talk about this more in length as we get closer to actually designing, but rotors for a little bit larger areas. So this kind of gives you an idea between 15 and 80 feet. Here are all the different types of rotors that we do have. Most manufacturers have them as well. We'll shoot in that distance. So a spray is the next one we're going to hit. So you can see right here, spray, no gears. Spray's a little bit more simple. It is spring loaded, but you can see the difference in the spray right there. It does exactly that. It sprays in a fan like instead of a rotor where it rotates. Now, where rotors were 15 to 80 feet, these typically shoot between 4 and 24 feet. And there are quite a few different nozzles. In fact, probably the best thing to do here is to get an idea. Let's see if we can screw this guy off. So here's a pop-up spray head right here. This may have water in it, and it may be frozen. It is frozen. Let me do this. Wow, that is frozen. I did. I pulled it out of the truck. So, most spray heads, you'll be able to screw off this top nozzle right there. And that still has water in it. So depending on how far you want it to shoot, you just pick a different nozzle. That's what you do. For example, this one right here is a 12 quarter. Shoots up to 12 feet. And this guy right here I brought has tons of different nozzles. Depending on the color, that's how far it shoots. Basically what it is. Now, recently, in the past, I would say 5 to 8 years, there has been a new hybrid nozzle for spray heads that has been developed. And instead of your typical spray pattern like that, oh, what did I do again? I don't want to start at the beginning. I'm going to do this. Okay. So this hybrid one, you see that one on the right there? It's similar to a spray, but with the exception of having an even pattern like that, it has each of these little fingers is what I'll call them. They're called a rotary nozzle is what they're called. Every manufacturer has a little bit different one. They're called a little bit different, but that's essentially what they are. The advantage of these guys is they're quite a bit more efficient as far as getting the water where it's supposed to go versus a spray right there. Sprays are typically known for being, for not getting the water exactly where you want it to go, that wind can easily carry the water away, whereas these rotary nozzles don't allow that as much. So there's basically two different types, which we've talked about. There's a fan and a rotary. Now, this is something you'll get into a little bit later as well, but you'll get into what's something called distribution uniformity. And I'll let Professor Kopp get into that in more detail, but essentially what distribution uniformity is it's, if you have a spray head right here, and it's supposed to spray 10 feet, how evenly does it water in between? Now, obviously, the more efficient ones are going to water evenly across that entire distance. And these rotary nozzles are typically much more efficient as far as that goes. There are many options as far as what you can put on the top of one of those spray bodies. These ones right here, the rotary ones, they actually shoot between, ours shoots between 13 to 24 feet is how far they shoot. So they shoot a little bit further than a spray head. Whereas these smaller ones right here, the sprays, they'll shoot between 4 and 15 feet. Okay, let's talk a little bit about drip now.
Hey, I've got a quick question.
Go ahead.
So are you saying all those heads are pretty modular? That you can just,
They are.
You have the spray body and you switch out the nozzles?
Exactly. So, and our head that we developed back in the 80s. Most nozzles, even by other manufacturers, will actually screw on to our body. Okay. And our body has kind of been the standard, so even other manufacturers make a body that has a similar thread and everything. So our nozzles actually end up on other people's bodies as well.
Your hybrid spray ones, can you adjust radius and distance on the one instead of changing out the nozzle? Like I have used it for the Rainbow.
Yeah. And Hunter's is very similar to, this is actually pretty new, ours is. And this will allow you to adjust the arc as well as the distance, is what it'll allow you to do. So that's this guy right here. That's what that one is. Kind of a handy little guy. Any other questions? And feel free to ask. Don't hesitate doing it. So we're going to talk about drip really quick now.
Hey,
Yep.
What about hard water? Does it ruin your nozzles? Does it clog up your thing? I mean, is that a real issue?
It is an issue. It is an issue. Those hard water deposits will end up, most of the time it ends up plugging up a nozzle. And that's why a lot of the times we make it so that you can remove it and replace it. It'll also affect valves and other things as well. Typically, most of our valves will last, I've seen them last 15 years, but I've also seen them last, a couple years, depending on the water situations. So like out in Cornish, for example, yes.
Okay.
We had pretty poor water out there.
So, we're talking 2 years? Or?
No, I would expect it longer than that. I mean, I would expect maybe at the most 5 to 6 is what I would expect. Now, in most cases as well, underneath that nozzle, you'll install one of these little filters as well. And that filter will catch some of the debris. But it depends on how poor the water is. Out in Cornish, where the water isn't filtered, yes, these will get plugged up fast.
So just a big supply on hand.
Yes. What I typically recommend to most people is that every spring you turn on your system and then you take off all the nozzles and blow these things out or just replace them every year is what I typically recommend, especially out where you are. Most cities like Logan City will have a filtration system where there's only a certain size of particulate or matter that will be allowed to come through. And we actually have these at a certain micron size that are allowable.
So that's really dependent whether you're on culinary water or on irrigation.
Yep, on secondary water. Exactly, yeah. And that's something that we'll get to with drip as well. We'll talk about in just a second. So drip, if any of you have worked for a landscape contractor, a lot of landscape contractors that I work with just do not like drip at all. And a lot of the reason why is because they can't see it working. It's something that the drip, as you can see right here, this is dripping out of the hose and dripping right at the base of a plant. And most of the people that I hear complaining about it complain that they just can't see it working and they want to see something working. However, drip is probably one of the most efficient ways to water, and that is because it gets right at the base of a plant. So it delivers water right to the root zone. It also, we talked about runoff a little bit earlier. It minimizes the amount of runoff. You also don't have overspray. It also, you can focus where that water's going, so you're not watering all this area and encouraging weeds to grow. So here is the makeup. A valve system is a little bit different in drip. Why is it different? Well, if you are using drip to water plants, you have these little emitters that plug into the tubing, and that little teeny hole is where the water drips out. So if you get any dirt or anything in there, it's going to plug pretty easy.
So hard water would.
Hard water eventually will end up plugging these, yes. What you'll find though is ours are designed, and a lot of manufacturers are designed to flush a lot of that out. But obviously with hard water it builds up and sticks as well. So in order to prevent any debris getting in, there are certain pieces of a valve, what we call a control zone kit for drip. And that's made up of these parts right here. First of all, you have a regular valve. So this valve is just like any other valve on an irrigation system. And then from there, it goes to a filter. So most of them, this is a residential size one right here. This is a filter right here. If you screw this thing off, you'll see inside of here, if I can actually get it out. Looks like I can't. There we go. That's actually a stainless steel screen, is what that is. So that'll pick up any dirt or debris as it's coming in and not allow it to go through the system. Oh, great. Now you fall out easy. There is also a pressure reducer. Now, can anyone guess why we might need to reduce the pressure when it comes to drip? Anyone want to take a stab? Aren't as resilient, maybe? That's exactly right. Well, let's go back to this picture back here. If you have high pressure, something I've seen quite often, if you have high pressure right at this joint right here, I've seen oftentimes this will pop off right here, and you'll walk by and there's a geyser popping out. So this right here, this little white tab that you can see right there, that white tab is actually a pressure reducer. So depending on what comes in here, it comes out at 30 psi. That way you won't get any popping. So those are the three basic components of a control zone kit for landscape drip, right there. And you're welcome to come up and grab this and play with any of it before you leave as well. So as far as the emission devices themselves go, there are three basic emission devices with landscape drip. The first of which is this one right up here. I don't know if any of you are familiar with this, but it's a tubing that has an emitter, and I have actually cut this away right there so you can see it. Has an emitter built into it right there. Water will come in, and it'll drip right out of that certain spot, just like it shows right there. A lot of landscape architects that I work with are specifying this on drawings. So this is one you need to become familiar with. Another one, so that's called inline drip. This is called point source. It's called point source because you can actually specifically draw it to the root of a plant right there and have it drip right at the root of the plant. And then also for other areas, like for example, say you have a huge annual area where it would not be efficient to use something like that. You can also use a drip mister. It's kind of like a mini spray is what it is. So that's kind of the very basics of a residential irrigation system. Any questions? Go ahead.
So this seems like something that you could use on a residential system using culinary water, but maybe on campus where, I don't know, I think they use canal water.
They do.
Can you
Yep.
use drip on something like that?
Yep.
Okay.
Basically what ends up happening is this control zone kit right here, this is a residential one. We have a commercial one that has a much beefier filter to it, and it also has an indicator light essentially up top that'll tell you when it's dirty, and then all you have to do is just take it off, clean it off, and you're good. Also, I know specifically the pumps that are used up here on campus, they go through a pump system that has a filtration process as well. But there'll be a lot of cities that have a secondary water system that is not very clean. I lived in Payson, for example, down in Utah County, and their secondary water was not very clean at all. In fact, I'm pretty sure that there was morning glory seed in the water. Because, man, when I watered, it was just like growing everywhere. I was like, what's going on? So that's an issue. It is an issue.
You just say the maintenance is a little bit higher for as far as commercial applications?
You know, yes and no. If it's installed properly, that's a lot of the challenge that we have is that it gets installed really poorly, like that the joints aren't put together properly. It's Some of this, for example, we have a product that can be installed underground. So from that standpoint, it's actually very, very maintenance-free. But stuff that's installed poorly, yes, can be very, very high maintenance. One thing that we've done as well to alleviate some of the issue of people not being able to see watering going on is we'll just put on like a little spray head. So when it turns on, it'll water that area so you can see it wet. That way people are like, okay, it turned on because it's wet right there. That helps a little bit. But you will get a lot of people saying exactly what you're saying. Can you really use that in a commercial setting? Can you use it on a campus? Can you use it in a park? Sure you can. It's used all over the state of Utah in those settings. Even though it seems like it may not work properly, it actually works very, very well. Any other questions? Okay. So those are the basics of a residential irrigation system. Kind of come back to where we started. Water is a precious resource. I would encourage you as landscape architecture students to become familiar with irrigation. As I visit landscape architecture offices, it seems like that there's two types of landscape architects. There's the artsy-fartsy type, and then there's the engineering type. And the artsy-fartsy type don't want to have anything to do with irrigation. They're just like, you know what, let someone else think about that. What I would encourage you, whatever type you are, you have to be familiar with it because it's going to continue. In the future, it's only going to be more and more of an issue in our role as landscape architects. And I'd have to say that as a profession, we do kind of have a black eye because we are not that familiar with irrigation as much as I think we should be. So that's all I have. Any other questions? Feel free to ask me. I do have any of this up here that you can come and play with. You can ask me questions after. Anything else you want to add?
No, thanks very much.
You're welcome.
I was just going to encourage everybody to hang around and have a closer look, perhaps, at some of the things that Brady's brought along. But that's all that I had planned for today. So if you would like to, again, please have a closer look. And thanks very much, Brady.